This is a quick review of our algebra proof, segment addition postulate, and segment midpoint problems. This is the first algebra proof. Remember, when you do proofs, they will give you something, and you always want to fill in the given first in the statement box. So, our given is 1/4 x plus 10 equals 2. Our first reason is always given. In a proof, we're explaining how to solve. So if I come over here and write this out, the first step to solving is to subtract 10 from both sides, but in a proof, we're not showing any of our work. So if I were to subtract 10 from both sides, I'd be left with 1/4 x equals -8, and that's what's going to be my next statement. Because I subtracted 10 from both sides, that's the reason that I'm going to write. So subtraction, property of equality. Lastly, if I were solving from this step, I would multiply by 4 on both sides. And I would be left with x equals -32. Since I said I was multiplying, that's multiplication, property of equality. Proof number 2 is really similar, so I'm always going to write down what I'm given under the first box in the statements. My reason is always given, and then I'm going to start solving. So if I were going to solve this equation, the first thing I would do is do the distributive property, and I would get -3x minus 6, and I'm going to rewrite everything else. The next thing I would do, and remember, there's more than one way to solve a proof, so really, these two steps could look different, but in the end, we're all going to end up with the same answer. So I'm going to add x to both sides. I would get -2x minus 6 equals 16. And so I said I would add x. That's addition, property of equality. Next step, I would add 6 to both sides. Again, since I added, addition, property of equality. Now remember, those two steps, we don't all have to have the same thing, but everybody's last step, we would end up dividing by -2. We would get x equals -11, and we should all have division, property of equality as our last reason. In this final proof, we start the exact same way, so we write what they gave us under the first statement. The first reason is given. If we were going to solve this, we would add 3 to both sides. I would be left with -10. That's addition, property of equality. To finish solving, since I have x divided by 3, the opposite would be to multiply both sides by 3. So x equals -30, and that's multiplication, property of equality. The second topic we're going to review is segment addition postulate, and this is the main idea. So the main idea is if I have this piece of the segment, AB, plus this piece of the segment, BC, it equals the larger segment, AC. So again, it's this small part, AB, plus the small part, BC, equals the entire thing. If we think about it with numbers, if AB is 7 and BC is 15, the entire thing would be 22. So that's the main idea behind segment addition postulate. For the first example, it gives you the segment and it says AB is 4x plus 24. BC is 5x plus 26. AC is 149. So the first thing you might want to do is label your picture. Now, it's the same idea even though we have expressions instead of just constant numbers. I'm taking this first small part AB plus the second small part, BC, and it's going to equal the entire thing. So 4x plus 24 plus 5x plus 26 equals 149 would be my equation. I can combine my like terms, so 4x plus 5x, 24 plus 26 equals 149. Subtract 50 from both sides. And lastly, divide by 9. And I would get x equals 11. You just want to go back up to the original problem and make sure that you just need to solve for x. And I do. So we're done with that one. Here's the second example for segment addition. So this one says AB is 100. BC is 5x plus 55. AC is 15x minus 35. Even though the setup looks a little different, we're doing the exact same thing. So remember, it's the first part plus the second part equals the entire segment. I'm going to combine my like terms, so 100 plus 55 is 155. I could subtract 5x from both sides. Add 35 to both sides. That would get me 190 equals 10x. If I divide both sides by 10, x would be 19. Again, you want to go back and read the original problem. So this time, it says find the measure of AC. This equation right here represents AC, and so we'll take our value for x, so 19, and we'll plug it in for x. And you should get 250. The last topic in this review is segment's midpoint. And the main idea of a midpoint is that it's the exact middle point. And so that would mean each segment is congruent. So here, AB is congruent to BC, which means their values are going to be equal. So AB equals BC. Remember, these marks here mean that they're the exact same. Using numbers, if AB is 7, we know BC is the exact same, so it's 7. The whole segment would be 14. So for our first example, it says AB is 12x minus 36. BC is 8x plus 40. Then it asks us to find the value of x. Again, since I have these marks, I know that these two segments, AB and BC, are the exact same. B is the midpoint, so I'm just going to set them equal to each other. When I solve, I can subtract 8x from both sides. Add 36 to both sides. I get 4x equals 76, and when I divide by 4, I would get 19. If I finish reading the problem, it says find the value of x. That's what I found. This problem is done. In our second example for segment midpoint, it says B is the midpoint of AC. So right away, I know AB and BC are the exact same. AB is negative 10x plus 29. AC is negative 55x minus 12. So make sure you're reading the problem very carefully, because if you just try to label without reading, you might have put this in the wrong spot. And then it says find the measure of AC. Now, this problem's set up a little differently. So last time we had AB labeled and BC labeled, so we knew to set them equal. This time that's not the case, but what I do know is that AB and BC are the same. So if AB is negative 10x plus 29, I can label BC the exact same. And now this is actually a segment addition problem. So this is almost like combining the two ideas. So I'm going to take AB plus BC equals AC. So the first part plus the second part equals the entire segment. When I combine like terms, I'm going to get negative 20x plus 58. If I add 55x to both sides, I get 35x plus 58 equals negative 12. I can subtract 58 from both sides. I get 35x equals negative 70. When I divide by 35, I get negative 2. Now, x can be negative, but your segment cannot be. So when I plug this back into AC, I should not get a negative segment. So this is AC right here. I'm going to plug in negative 2. I would get 110 minus 12, which is 98. So again, x can be negative, the segment can't be. On the very last example, we're just going to set up each problem. We're not going to solve. So this first problem is an example of segment addition. So I have the small segment plus a small segment equals the whole segment. So my setup would be 2x minus 9 plus 9x minus 17 equals 144. In my second problem, I have these marks, meaning that B is the midpoint. I know that each part is congruent, it's equal, it's the exact same. So I am going to set those two equations equal to each other. In this third example, it's kind of a combination of the two. So I see the congruent marks, meaning that their measures are the exact same. So if AB is 2x plus 15, BC is also 2x plus 15. And now I know that AB plus BC, so each part, 2x plus 15 plus 2x plus 15 equals the entire thing, 95. In the very last example, I actually don't have enough information to set up an equation. And here's why. So first, there are no congruent marks, so I don't know for sure if B is the midpoint, even if it might look like it is. So I can't set those two equal to each other. I also don't have a total value for AC, so I can't do segment addition either. So this one, we just don't have enough info to write an equation.